Good afternoon, everyone. Welcome to the webinar series QuEra with Friends, organized by QuEra Computing. My name is Tommaso Macrì. I'm the Executive Account Manager at QuEra, and I'm happy and honored to present our esteemed guests for today. Dr. Leandra Olita from the Technology Innovation Institute in Abu Dhabi. She's the Chief Scientist there. And Mr. Feras Jabi from ITQAN, General Manager at the company. The agenda for today is the following. I will start with a broad introduction about the technology at QuEra and potential commercial opportunities in the region, and then I will give the floor to my guest from TII and ITCAN. We will conclude towards the end with some opportunities for collaboration and with some brainstorming discussion with our guests. Of course, if you have any questions, feel free to drop them on the Q&A section here on Zoom. We are very happy to interact with all of you, and feel free to also to follow up with any of us after the presentation. So let's start with some basic information about QuEra. QuEra Computing is a quantum computing company headquartered in Boston. We are at a bike ride from both the Harvard and MIT. Our mission is to build and productize quantum computers based on a specific technology called neutral atoms, which is considered by many one of the most promising technology for both scalability and error correcting properties. We have one quantum computer which has been deployed on a major public cloud since November 2022, and we develop application across multiple areas in quantum simulation, machine learning, and combinatorial optimization. Let me tell you a little bit more about the perspective of quantum computing with neutral atoms. So why are neutral atoms considered one of the most promising technologies? So first of all, we use atoms as fundamental qubits. They are all identical, pure, and resistant to noise. So differently from other approaches, such as the ones that utilize artificial qubits, neutral atoms respond to external fields all in the same way. The second important feature is that by now we have demonstrations with a few thousands of qubits, but we plan and we believe it is possible to scale them up to a few tens of thousands of qubits without requiring complex interconnects between different quantum processing units. Third, there are certain capabilities that make the layout for the computation much more reconfigurable, and it allows for long-range connectivity, removing complex overhead required to transfer information between distant qubits. Last but not least, the device that we are currently building operates at room temperature without requiring any kind of cryogenics, which reduce therefore the complexity and the footprint of our devices. All this technology has been extremely relevant to build our third generation of quantum computers that has been on the cloud for more than 2 years. The uptime of this device is about 130 hours a week, and it is still the largest quantum computer available on a public cloud in terms of number of qubits. The use of Aquila, which is the name of this quantum computer, has resulted in several exciting scientific publications, and this has also sparked the attention of many initial customers to engage directly with the QuEra scientists. So since then, a lot of progress has been done within the company, and we reached an important tipping point by deploying our second quantum computer at AIST, which is the National Institute for Standard and Technology in Japan, right outside of Tokyo. It is a 256 qubit machine based on the gate-based or digital paradigm for quantum computing. And as a kind of computer, it is very well suited for integration with HPCs. Indeed, this device that you are seeing here on the slide has been installed alongside the ABCIQ supercomputer that hosts a bunch of GPUs from NVIDIA and a quantum node provided by QuEra. Importantly, in terms of applications for this device, we are also starting to look at very early fault-tolerant or early-stage quantum error correcting demonstrations. And QuEra is very well positioned in this space. It is considered to be one of the leaders in this area. And what you can see is that we were essentially nominated as one of the breakthroughs of the year by the journal Physics World. So with this, of course, I'm happy to take additional questions in the chat and respond to them throughout the presentations of our partners. I would like to give the floor to my colleague Leandro Aulita, who will talk about the activities in quantum from TIR. Please, Leandro, the floor is yours. Feel free to pull up the slides.
Thank you very much, Tommaso. Good afternoon, everybody. Thanks for the invitation to tell you about the efforts in Abu Dhabi. Let me share my slides. Please moderate me, Tommaso, in terms of time. I'll try to make it short.
Absolutely.
Thanks. So I'm Leandro Aulita. I am the chief researcher, the chief scientist of the Quantum Research Center. I will tell you about the efforts. So this is a world-class quantum technology hub that we've established in the Middle East, and I would like to walk you through it. Let me first show you. So this is not going to be a technical seminar. I'm going to tell you mostly about the structure and the efforts and some main achievements we have had. So first of all, let me tell you some statistics about the center. So we're almost 90 people. I think now we are 95. We have a big component of national UAE national Emirati researchers, and we have many publications since we started. We've been here in the country for only 4.5 years, the first ones to arrive. We have several collaborations agreements with industry and academia, and also patent applications. I should also clarify that we're not an academic institution. We do have academic activities. We publish papers. We still go to conferences, but we're an product-driven and application-driven research institute, right? So many of the things we do, many of the research that we do does not end up in papers, in scientific papers. We do lots of R&D contracts with companies and proof of concept, right? So let me tell you about the structure. We have 6 different divisions in the Quantum Research Center. We have 3 theory divisions, the Quantum Algorithms Division, Quantum Middleware, which is essentially software, and Quantum Physics Theory. And then we also have 3 experimental efforts, quantum computing hardware, where we have a superconducting qubit device experiment. I will show a slide on that. We also have a very strong team on quantum communications and also on quantum sensing, right? I won't probably have time to discuss these 2, but I hope I can tell you more about the computation, the quantum computing efforts, which I think is the most relevant thing to discuss in this space. Let me then go to the next slide. Yes. So let me tell a little bit about the hardware effort. So we have a world-class lab. We have several fridges and we have also our own foundry. We can print chips. Currently, we work with superconducting qubit devices, and we have transmon qubits. You can see here, these are the first quantum chips produced in the Arab world. So we have a mixture between quantum chips that we produce as well as quantum chips from other hardware providers that we lease, right? So currently this year we want to go to 5 qubit chips produced here in-house, but we have quantum chips of up to 25 qubits here. And there are also plans for expansion. And in fact, we're talking also, one of the things we're discussing is also with Tommaso is, expanding to other type of physical platforms. But we have a very strong team with very strong ambitions. Like I said, not just manufacturing, we do characterization, calibration, and of course, gate implementation. So we're moving to a fully sovereign and autonomous experiment here in Abu Dhabi on on quantum computing hardware. I should also say that we have the full stack approach to R&D and quantum computing. So we have, like I mentioned, the quantum middleware division. This is about software. So our flagship product is called Kibo, which is the open source operating system that we have, not just for operation, but also for calibration, characterization, and even simulation. Also, we have classical simulation backends for quantum devices. This is what we do. This is what we use here to control our own quantum hardware. But there are also other people in different labs in the world that are interested in adopting it. There are people interested in it in Germany, in Singapore, also in CERN. So this is an open source software effort that we're leading here at TII. Then, of course, let me tell you a little bit more about the quantum algorithms division, because this is maybe the most relevant division that we have in terms of potential interactions with QuEra. Of course, at the level of quantum hardware, there are things that we can explore, but like I said, for the moment, our experiment is focused on superconducting qubit devices. But we do have lots of things that we can discuss at the level of algorithms, and we've been chatting about these possibilities with Tommaso. So I don't need to tell you the story of quantum algorithms. They are interesting for many applications. Here we're, of course, particularly interested in oil, gas, and energy, but there are, of course, things connected to optimization in logistics, big effort being put on chemistry and materials, right? And of course, lots of things that we expect also on the machine learning side with applications in finance and insurance, right? And risk management. So let me tell you how we structure the group to give you an idea. Within the quantum algorithms division, we have three main verticals. We have the quantum enhanced algorithms vertical. This is really like proper quantum algorithms. We have a big effort on characterization and benchmarking methods. This is what we need for calibrating and characterizing quantum hardware, also for developing noise mitigation and quantum error correction schemes. And we also have something nice, which is quantum-inspired algorithms. This is not quantum, this is classical, but it's an intermediate step towards quantum. And it's useful for us to speak to industry and do proof of concepts to industry. And they serve us as an intermediate step to what really end-user application in the future with quantum algorithms, right? So that's the main structure here. You will see in quantum-enhanced algorithms, we tackle applications on the NIST era, but we also look at advanced algorithms for future fault-tolerant quantum hardware, and we do lots of activity connected to early fault-tolerant machines, right? I won't be able to walk you through the different contributions that we have done over the years. Here you can see a selection of publications, mostly from the last 2 years. So you can see that we have many things going on algorithms, benchmarking and characterization, also quantum inspired. So this is just to give you an idea of the scope of activities that we do. And as I was mentioning, our focus is not just on industry, on academia. We're actually an application-driven research team. So for instance, here you can see things that we've been doing on this slide with quantum-inspired algorithms for computational fluid dynamics. So we were finalists on this Airbus BMW Quantum Challenge that happened last year. We were in the final in Silicon Valley in the Q2B conference. And this was for a new algorithm for solving computational fluid dynamics using tensor networks. This is a well-known tool for quantum-inspired algorithms in quantum computing theory. We're also doing interesting things on protein packing, protein design. This is interesting for drug design and other applications, for instance, carbon capture. So protein packing is a little bit the opposite of protein folding. In protein folding, you're given a sequence of amino acids and you need to predict the fold into which the sequence will fall. In protein packing, it's the opposite process. You're given the fold, a target fold. You want that fold because you want that structure to pack, to dock onto a target protein. And given that fold, you're asked to predict the sequence of amino acids that produces that fold. So we have very interesting quantum-inspired algorithms also in that direction. These are benchmarks with Rosetta, which is a state-of-the-art physics-based solver. So blue and orange are curves. The more to the left, the better. And black one is the Rosetta solver, which is the benchmark. This example here is proteins of size 469 amino acids. This is already commercially relevant, and we have significant runtime speedups here. So like I said, I'm showing only quantum-inspired algorithms, but this is all within an effort to really integrate, high-performance computing, deep learning-based methods, quantum-inspired algorithms, and of course, quantum algorithms, right? So I think that's pretty much the core that I wanted to show you. If I have a few minutes, I can very quickly walk you through the quantum communications and quantum sensing slides. And with that, if that's okay, Tommaso, so let me very quickly go through there.
Go ahead.
So we have, like I said, so far I have covered the divisions that work in topics connected to quantum computing, right? So I talked about quantum computing hardware. I mentioned the efforts on quantum middleware, and QuEra, and then I devoted a few slides to quantum algorithms. All of that is directly connected to quantum computing. We also have a strong team on quantum physics theory that they cover the physics of superconducting qubit devices. Is interesting because we can play with new designs. Since we have also a quantum foundry, we can try different ideas, right? Is that a question, or what was that, Tommaso?
Excuse me, Leandro, say again.
No, I thought I saw a question by someone. There's something in the chat.
I can ask, if you like, I can ask the question right now. Or
let me finish here, and then we can. Yeah. So yeah, I was talking about superconducting qubit circuit theory, and also there's activities connected to atomtronics and neutral. This is also connected to quantum simulations. So that's still quantum physics theory group. We have a very strong team on quantum communications. Here, this is one of our most applied teams. They don't have such a strong, let's say, academic profile, but they are tremendously strong in what it comes to quantum engineering and very advanced in terms of technology readiness level. So we have QKD systems, both via telecom fiber and also space to ground. We have a ground station, an optical ground station here in Abu Dhabi for space to satellite communication. But in terms of optical fiber QKD, we have systems that are very close to commercialization, actually. And so there are some possibilities of venture here. We have some local clients interested. So that's our QKD receiver and sender setup. I wanted to show also what I was mentioning. So this is our optical ground station. So in the near future, we want to have QKD sessions between a moving satellite and our optical ground station. This is 45 minutes outside of Abu Dhabi drive, and you can see, well, here's the station, and inside of it, there's the QKD receiver module, right? So this is very advanced. Also, there are many people interested in the region. This is, of course, connected to cybersecurity and defense too. And finally, I wanted to mention the efforts that we're doing on quantum sensing. So this is also a team that is both strong at the academic point, but also at the engineering side. And here we have activities on linear accelerometers and also magnetometers. So magnetometers is something important because it's relevant for GPS-less navigation. There are many things to do there. And we're partnering with local stakeholders like the Abu Dhabi National Oil Company, for instance. So yeah, this is very exciting and fun effort to do. And with that, I would like to thank you very much for your attention. And of course, I'm happy to take questions if time allows. Thank you very much, Tommaso.
Thank you so much, Leandro, for the very nice presentation. Before giving the word to Feras, so Feras, if you want to start pulling up your slides, there are two comments that I wanted to make. Actually, one comment and one question for you, Leandro. We were asked by the audience whether we can share the presentations. What I can comment is that we are planning to publish the presentation on QuEra's YouTube channel after the webinar finishes. And the second, which is more on as a more of technical question for Leandro, we have the participant, the attendee says, in the protein packing solution that you presented, is the speed up of 70 per compared to traditional HPC, GPUs, or AI enhanced techniques as well?
Oh, these benchmarks are only against Rosetta. Rosetta is a solver that is physics-based, actually, and these are on proteins that are parts of that benchmark that is well known. The problem when you compare a physics-based solver with an AI-based solver is that most likely this instance, the particular protein that we're looking, which is in a well-known database, is very likely part of the training set of AI solvers, right? So we have very good results as compared to Rosetta, which is the state-of-the-art physics-based solver, and we're now working on an integration with deep learning-based methods and things that involve AI. So what we have can be very smoothly integrated with AI-based methods, and we're working on that. And in fact, we're partnering with, let's say, partners from the biotech sector also to look at cases of proteins that are not within training sets of AI-based models, right? Because it's difficult to compare when your benchmarks are already inside the training set of an AI-based method. But the nice thing is that it's smoothly integrable to that, right? And so yeah, and that's kind of something that I'm showing. We're not publishing that because that's more on the commercial on the commercial side. So there will be a publication at some point, but not yet. I hope this answers the question.
Yeah, I think so. Leandro, I have another question, perhaps a little bit more general, and then we can go a little bit more into the details. You showed in the last part of your presentation some interesting directions in other areas of quantum technologies, actually beyond the quantum computing. Is it clear that in those areas the path to commercialization is actually closer than what we would expect for quantum computing? Do you have any expectations for these areas more broadly, or is it still unclear where we could where we are headed to?
Are you referring to classical quantum inspired algorithms, for instance?
No. You also mentioned briefly the communication and sensing part efforts of the AI, and I want you to kind of compare them to the activities that you are doing in computing, and also to kind of set the right expectations for the companies and the institutions that live within your ecosystem.
Thanks, I understand. The most advanced product that we have at the Quantum Research Center in terms of technology readiness level is our QKD systems, especially in particular for key distribution through optical fiber. So that's ground to ground. Of course, this is still experimental in the sense. So I mean, the receivers and the senders, these are systems that are working very well. We have benchmarked them extensively with other systems, both commercial and experimental. But you know that QKD still faces many roadblocks. There are many problems, right? So for instance, you cannot do quantum key distribution sessions beyond, let's say, 50 to 80 kilometers through optical fibers because you have attenuation. You're sending single photons after all, and so then you need to rely either on repeaters, or you need to integrate that with this satellite to ground distribution schemes, right? So we are tackling that like full stack. We're really looking at all the problems. So I should also say that in TII, we also have a very strong center focus on cryptography and crypto encryption. So they work on post-quantum crypto algorithms, right, which are classical algorithms, but it's also connected to quantum resistant cybersecurity. The thing is that we see already demand in terms of, especially here, like there are, in a first stage, it's more demand for proof of concepts, but we see a strong commercial potential there, right? There are the big stakeholders, both from the private and the governmental sector, that that are constantly reaching out to us for having different types of deployments. So this is something on which we will probably see ramping up over the next couple of years, and there might be some venture starting. So I should also mention that TII is part of a conglomerate of companies. TII is actually the research leg of something more broad, which is called the Advanced Technology Research Council, and there is also a commercialization leg, which is called Venture One. So we have the, let's say, juridical means to spin off startups, for instance, right? Within the ATRC ecosystem, right? So one of the things on which this is moving is really to have commercialization activities of quantum key distribution systems in the country, right? So although it is still an experimental technology, we see already some demand. Yes.
Excellent, excellent. Thank you so much, Leandro. Perhaps we can continue the discussion after the the presentation from Feras and my conclusions. Why don't we allow Feras to pull up his slides? Can you stop sharing, maybe, Leandro?
Oh, so I didn't. Sorry. Yeah.
Feras, can you? Let's try.
Yeah, thank you. I'll just thank you. I hope you can see my screen.
Yes.
I'd like to thank everybody for being with us today, and like to limit my time with the permission of Tommaso as the moderator to give more time to the audience to get in depth to the subject of this webinar. I'm just trying to highlight for everybody that my name is Feras Jabi. I'm the General Manager for Technology Group of Companies under an umbrella of YAS Holding. We are headquartered in Abu Dhabi with an existence in UAE. To give you just one more slide about ITQAN, and a company that's been established in UAE since 1984, a systems integrator, solutions provider, and part of a group of IT companies in software and cloud and high performance computing, been an intrinsic part into ITQAN. And that's why we have this chance to partner since 2 years with QuEra to start bringing to the audience in the academia and different verticals in UAE about the quantum computing. This is who we are and what we do, and the market verticals that we exist ever since our establishment in 1984. We've been happy to be a contributor and major player in multiple verticals and into the forefront technologies ever since the shifts happened in the industry. I'm happy to take any questions and happy to get engaged more with everybody from this respected audience. In collaboration between us, Quantum and TII, we would like to drive more sessions around this topic and engage you more, our respected audience. And in this think tank of ideas, how can we build collaborations between different verticals, engage more leading institutional organizations like the ones that I can see present today from Khalifa University, from Ankabut, from American University in Sharjah, from multiple organizations. We are so glad that you are in, and to our respected audience from whatever organization or region that you are joining, we are open for collaboration. I noticed some of the points and the questions. New York University is one of the leading organizations that are present today with us. Thanks for contributing. Abu Dhabi Ports Group and many others that I consider them at the leading and in the forefront of driving innovation into their operations. So as promised, I'll not take much time. I'm just here to say that we are the partner and representative of QuEra in UAE and GCC, and happy to facilitate any dialogue that we'd like to do it. Our plan is to make this webinar more often. Maybe in a couple of months after summer, we will introduce a new agenda and a new forum. Happy to hear your comments and suggestions, and happy to have you all and your fellow friends part of this forum in order to drive and promote the evolving of quantum computing in our region. That's all from my side. Thank you very much. I kept my email in the chat. If you'd like to reach out to me or to Tommaso or Leandro, please feel free. Thank you.
Thank you, Feras, for the introduction of ITQAN and the broader holding. Maybe if you have 1 second, so I see that are you still? Yeah, you can hear me. Maybe
Yes.
on a kind of broader level, of course, you compare to other institutions that are more targeted to kind of showcase the usefulness of quantum computing and quantum technologies more generally. You are very much targeting several industries, industry cases, and so on. How do you kind of gauge the interest towards this new direction of quantum computing in the area from big organizations? You mentioned a few in your on your slides. Do you see an interest towards quantum as a kind of accelerator of classical computing technologies, CPU, GPUs, and so on, or what is the feeling more broadly in the Emirates?
I think the waves that we had seen in demand of high performance compute and in a powerful computing platforms that satisfies the innovation, the research, and the development of so many initiatives, especially in AI, in pharmaceuticals, in physics, and in science and in academia. For certain time and until now, it is fueled by the high performance compute with the traditional GPUs and CPUs and different platforms that serves the researchers or the different industries demands. And I see that the quantum computing is coming with a promise that will build on this, let's say, revolution of demand in terms of computing resources, despite all the factors that we still need more software, more platforms, and more probably research to happen in order to bridge this gap. The first thing I see is really an extension for the high performance compute demand, and that will help in relying in more, let's say, contained, however powerful computing source like QuEra, which we've seen in your first and second slides, Tommaso, that does not require that much of resources in terms of cooling, power, and environment, yet can deliver at the same time the availability of the quantum computing for testing and research over the cloud. And I think it is known for many that the AWS cloud is operating on QuEra computing, and it's available. So I believe we need really to get this momentum with the help of the respected audience like the ones that we had seen today. And we need all of you to help us to craft the future of quantum computing in UAE and in the region. I cannot decide anything on my own, and I cannot predict without building this forum to be a frequent and active forum. Thank you.
Thank you, Feras. Let me perhaps share a little bit more context regarding the activities that we are planning together with our partners. I hope that you can see my slides, correct?
Yes.
So in general, at QuEra, we love to interact with academics, government, and industrial partners within 3 main pillars. The first one that I already mentioned in my first few slides is about accessing our quantum computers either through our cloud services or through an on-prem solution. And this can come with, of course, some support and services to build the the quantum community around these devices. The second one, which is something that was also mentioned by Leandro as one of the directions that could be pursued with some academics, is more related to collaborative research on some very crucial items related to the development of quantum computing. For example, quantum error correction, to really build and create and commercialize fault-tolerant devices in the next few years, but also to start exploiting the connection of quantum computers to classical HPC systems by developing, for example, hybrid algorithms that could be enhanced by the use of AI in very different sources. The third pillar is more targeted towards the development of applications for specific business verticals or industry verticals, such as pharma, as we heard, but could also be finance or logistics, for example, through a very collaborative process that will involve both research teams from the partner institution as well as QuEra scientists. And this involves, or the target or the goal of these interactions is really to build a pipeline that will start with the concept idea related to the business or industry vertical into potentially a solution that could be eventually integrated into the business workflow of the partners. So all of this started, of course, very long ago in terms of brainstorming ideas on how to implement these directions more effectively. And as part of this process, towards the end of 2024, we started basically by creating the so-called QuEra Quantum Alliance that takes together a series of partners, including ITQAN, that is present here in the audience, that are displayed a strong interest toward the development and the commercialization of quantum computing based on QuEra's neutral atom platforms. As you can see, there are system integrators, HPC centers, several quantum companies from all around the world. And of course, if you're interested in joining, feel free to shoot us an email at tmacri@quera.com. Reach out to any of us, both myself as well as our colleagues Feras and Leandro. And with this, I would like to essentially conclude our presentation, thanking again my partners, Leandro from TII and Feras from ITQAN. I'm happy to take further questions after we finish our presentation. Thank you so much, and looking forward to speaking with you again. Thank you.
Thank you very much.